Hello friends, this is Partho sir. Today we are going to discuss some of the important problems based on current electricity. Now in the recent trend of IIT Advanced and JEE Main, we have seen certain problems from the current electricity chapters is coming from the 3D network. Now today we are going to discuss one important problem based on current electricity on the 3D network. Now see, here it is mentioned the equivalent resistance between E and F is Kr by 5. We have to find out the value of K, where it is mentioned all the resistors is having an equal resistance, that is R. What we will do, first we'll see the symmetry of the circuit. Now see, between the point A, E and B, there are practically two resistors exist, and between the point E and F, another resistance R exists. In the triangle, if you see DFC, there are only two resistors exist, and between this E and F only one resistance exists. Other two resistors are between B and C and A and D. So this two triangle, that means triangle AEB and triangle DFC, these two triangles are symmetric in nature. So what we'll do, we'll just check out the potential of this point B and potential at this point A, these 2 points having the same potential, because VA is equal to VB, and simultaneously potential at this point D and the potential at this point C, this also having the same potential. Now what we will do, we will just renovate this circuit. It is this circuit E. Now if we draw this circuit in this manner, so we can take it into this shape where the point A and B, these 2 points will converge over here, and another point, that is if these 2 points converge over here, so there will be another point, that is F. So this F point ultimately will come down over here, and it look like this. Whenever this D and C will merge together, so it will converge once again. So this D and C point have the same potentiality, that same potential. A and B also have the same potential. So if we just short this particular, this is basically no current is passes through it, so we can short this particular 2 points. So what will happen, that this is just an F point, and we will draw this circuit like this, where it will be R. So this will be R, this will be R, this will be R, and this will also be R. Now between the point C and D, there is another two resistance exists, that is between C and B one resistance, that is this one, and this was another resistance we have seen, that is this one, and another resistance exists between A and D, that is this one. So now what we will do, we will just converge these two resistance over here. This is the way. So once we will converge these two resistance over here, so ultimately we will get the full circuit. Now there is one cell we have seen which is attached with between the E and F, and we have to find out the equivalent resistance between E and F. So we will just connect this two. So ultimately we will get the entire circuit. Now first, for this portion we can see the equivalent resistance will be, this will be in parallel, so R by 2. This also, this position, this are also in parallel, so you can write down R by 2, and ultimately this portion also in parallel, so it will be R by 2. So if we just simplify this particular circuit, it will come down to this way another resistance, and this is another resistance, so it will be R by 2, this will be R by 2, and this also will be R by 2. And the resistance between point E and F, so it will be like this, so it will be R, and the cell portion will remain like this, so this will be your cell. Now what we will do, we will simplify it. This portion will be 3R by 2, and if we simplify this particular resistance, then we will get another resistance, that these three are in series, R by 2, R by 2 and R by 2, these are in series, so we are getting this 3R by 2, the total resistance. And the ultimate circuit will become like this, where you find this is E, this is R, and this will be 3R by 2, and this will be R. So this is the ultimate resistance, and the other cell is attached to it. Now the equivalent resistance between E and F, so the equivalent resistance between E and F will be 3R by 2, because these two will be in parallel, so 3R by 2 into R, that is 3R by 2 plus R, it comes down to 3R square by 2, and this will be 5R by 2. So 2 will be strike it down, 1 R will strike it down, so ultimately it comes down to 3R by 5. Now it has been mentioned that KR by 5 is the total equivalent resistance, so ultimately equation comes down to 3R by 5 is equal to K into R by 5, because as it was mentioned, so ultimately the value of K which comes down to 3. So this will be the answer of this problem. Thank you very much.